Testing, testing. Right, hello, this is C++ and we're on chapter 5. We're going to be looking at two student shared data files, figure 05_07 and figure 05_08, found on pages 173 through 175 and 175. Figure 5.7 is our interest.cpp driver program. And we see that we are including our IO stream, IO manip string, and we are going to be creating our own header for the dollar amount class object. Our driver program then has the main begin and end. And figure 5.8 is the dollar amount.h, our header file, which creates our dollar amount class objects. We have an include string and an include C math. C math is from our standard library for including our math functions, and we'll see that we're including a power function. And we'll make use of that in our code as we come upon that section of code. In order to make use of the POW method, we must include the C math standard library. All right, so let's look at the dollar amount.h object class header file first. So I have my class dollar amount begin brace. I'm just going to follow down until I find the end brace. And remember, we end with a semicolon on our header files. As I create a new class object, I would like to look at its private data members first. And I have an int64_t as a data type. That is a special data type that allows us to express long integers. As data types. Allowing us to support the exact range of, and that's on page 177, an int64_t declared identifier will be a long int, which supports the exact range of, and that's a very, very, very small integer number to a very, very, very large number. So we're dealing with quite a bit of accuracy by declaring amount as an identifier name for our dollar amount class object. It's a private data member named amount of type int 64_T. I just made a little note here in my UML that we are declaring on instantiation of a new dollar amount object. That amount will be initialized to 0. We did that with the initialization braces. Continuing to draw the UML schematic and familiarize myself with the code. We have our constructor, dollar amount, and we're expecting an int64_T data type to be shared or sent to us, passed to us from the driver. And we're going to initialize that then to amount. So amount will be initialized to value. So on instantiation, amount will be initialized to the value passed as an int64T data type. Next, we have the add member function. And the add member function syntax we have a public add. The identifier name is right, and it's expecting that a dollar amount, and this is a class object. We're now passing an entire object to a data member function. We're used to passing integers and doubles and strings. Now we're going to actually be passing to the public member function add a variable by the name of right that is of type dollar amount. It is a class object. Subtract is a member function. It is public, and it too has a variable name of right expecting to be passed a dollar amount class object. We have add interest rate, a member function known by all objects of type dollar amount. Add interest is expecting 2 values to be passed to it from the calling environment. Both will be of type int. We have a rate identifier and a divisor identifier, both of type int. And finally, we're introducing our toString member function. toString is a public member function of dollar amount class object, and it's going to return a string to the calling environment. So then our driver program, and I have both files now, source code printed and sitting close to me so I can work back and forth. You may have your textbook open too, that might work. All right, looking at our driver program, we now know what our class object dollar amount consists of: a private data item named amount of long integer, int 64_T data type, and we have its constructor, and we have several public member functions. Well, the first thing we're going to do is instantiate, create a new class object. It's a new dollar amount object named D1. So in current memory, I have dollar amount objects being instantiated. The first one is D1, and it's pointing to the class object of dollar amount, which has a private data member amount, and I'm now going to initialize it to 1, 2, 3, 4, 5. Remember that all dollar amount objects remember or have access to their own data members throughout their lifetime. So D1 will always know its dot amount value. We're going to instantiate another $1 object in current memory. We're going to reference it with D2 as an identifier name, and I'm going to initialize it to 1576. Now, in our beginning core code dissection discussion in the textbook, and now in our beginning documentation line, it says that we're going to be calculating compounded interest calculations with class, dollar amount, and integers. Normally, when we think about monetary values, we think about decimal points, particularly dollars and cents, 0.00, 2 places following the decimal point. And here we're going to be manipulating all of our dollar amounts in pennies. So we've made that conversion. 123.45 is 12,345 pennies, and $15.76 is 1,576 pennies. Now, don't be intimidated by this program. It is quite involved, but we are studying object-oriented programming, and we will look at a lot of new features, including algorithms, logical ways to solve programs, and we just spent time in our first lecture discussing the trade-off, round-off errors, and misrepresentation with floating point numbers. So we want to be very accurate, and we're allowing ourselves to be very accurate by converting monetary values to integer values. Next, we have a cout in line 13. So I'm going to line 13, and this is output. I'm just going to reference line 13. In line 13, it says, after adding D2, I'm quoting yet, the open paren, that's the end of my string. After adding D2 open quote, now I'm going to continue to output with D2 object in hand. I'm going to call the toString method. D2 is a dollar amount object. D2 is a dollar amount object, so it knows its public toString method as a task it can perform. So I have with D2 dot toString, I'm calling the toString method, and the toString method is line 35. Of my header file. My member function is going to return a string. ToString is the name of the member function. It's going to return one item of type string. So I have called d2.toString. In d2.toString, I have an open and a close. I'm going to begin with, I'm initializing a string by the name of dollars. I have a variable by the name of dollars. And I'm going to initialize with the braces. two-string amount divided by 100. Remember, we are calling D2 two-string. D2 two-string, that's D2 dot amount is 1576. So D2 dot amount is 1576. So I have 1576 that I'm bringing in, and then I'm going to divide that by 100. One five seven six divided by 100 is 15.76. Remember, this is integer division, so I have 15. So dollar is equal to 15. I'm continuing. I'm going to return a type string, declare a type string with the name of cents. I'm going to initialize it to, this is with D2 in hand, so I'm using D2 dot amount, D2 dot amount. I'm using the absolute function. The absolute guarantees that I return a positive value. D2 dot amount is 1576, and I need to get the modular arithmetic divisor remainder when I divide by 100. 1576 divided by 100 is 15. 100 goes into 1576. 157. This way. 15. 500 with a remainder of 76. Now I'm asking for the mod. I'm asking for the integer remainder of D2 dot amount divided by 100 and return the integer. So I have 76 as an integer. Now we're going to return dollars. Dollars value is 15. Plus, I'm continuing with a decimal point, quoted, plus cents.size. Now cents.size will return the size or length, the capacity of the cents variable contents. And we have 2 digits assigned to cents. So cents.size is 2 equal to 1. I'm looking for the relational equality test. 2 is not equal to 1. So I'm calling the question, here's the true path and here's the false path. So I do nothing. That's a null quote. And I'm going to output, append to output 76. Now I'm back to line 13, my output line in my driver program. So I've got the value of D2 in monetary value converted with my two-string function. It knows how to convert from pennies to dollars and cents representation. I output that value. I'm going to continue to output a and quote, a closing quote. I'm continuing with a blank space into D1 with an quoted open parenthesis. And now I'm going to continue, and this will continue on one line of output. I'm going to output D1.toString. So D1.toString is called. It's a member function of our dollar amount class object. So D2 as a dollar class object knows it can use the member functions, and member functions of dollar amount include the public member function toString. So I'm calling with D1 class object in hand. I'm going to call the toString method. toString is in the class header file, and its member function toString is going to return a single string value. Again, I'm declaring string dollars known to this method, this local method only. And I'm going to call toString with D1. Remember, we know it's the object D1.toString method we're calling. So I'm looking at D1.amount, and it's 1, 2, 3, 4, 5. Integer division by 100. Integer division, 1, 2, 3, 4, 5 divided by 100. I'm looking for the integer portion only, so dollars is assigned 123. And I'm continuing to process. I'm declaring cents known to this function as a local variable. I'm calling the toString method again with D1 in hand. D1 dot amount. D1 dot amount is 1, 2, 3, 4, 5. I'm going to use its absolute value. And I'm going to look for modular arithmetic dividing by 100. So 1, 2, 3, 4, 5 divided by 100, and I'm looking at the remainder. The remainder is the integer 45. So cents is assigned 45. And that's D1 dot cents is assigned 45. I'm continuing in the return toString method. I'm going to return dollars, and now I'm continuing on one line of output. I guess I didn't leave myself enough room there. So it's going to be 123 for dollars. Plus, I'm going to continue to output a quoted period. Plus, I'm continuing to output cents size. I'm looking for the size of the cents variable characters, and I have 1, 2 characters. 2 is equal to 1. Is that true or false? That's false. So I'm going to do the false portion, which is nothing, and I'm going to output cents, which is 4, 5. Going back to my driver method, and I've output D1 toString converted to a monetary value. And it continues by outputting the quoted close brace and a comma and D1 space D1 space equals quoted space. I'm right here ready to output. And my next statement says D1.add D2. So I have with object D1 in hand, I'm going to use its member function add, and we're supposed to send a dollar amount object and call it write. So I have D1.add, and I'm sending D2 passing D2, and D2 is an object. So it has to be a matching dollar amount object, and now for the duration of the add method, I'll be referring to it with its local variable write. So in the method D2 dot or D1 dot add in the header file, my dollar amount dot h knows its own data and member functions, and here's void dot add. I do have a dollar amount data type required, and I am passing D2 as that object to the variable write. And the task is to, remember it's D1 dot amount. With my D1 amount, I'm going to plus equal write, which is actually has actually been passed D2. So D1 dot amount, D1 dot amount is 1, 2, 3, 4, 5. I'm going to add D2 dot amount referenced by write 1576. Remember our plus equals, I add to the current value of D1 dot amount 1576, and the new value is assigned to D1 dot amount. And my new, what? 1, 2, 3, 4, 5 plus 1576 is 13921. So after my plus equals, the one dot amount is going to be reassigned to D1 dot amount plus 1576, which is D2 referenced by write dot amount. D2's amount is 15.76. So I am now overwriting D1 dot amount with the plus equal has been reassigned to 13921. So I'm done with this statement. I go back to my driver, which called the method add, and now I'm ready to continue to output D1.string. D1.toString. D1 is an object, and it knows its own methods. So I can use toString as a class member function of dollar amount. So now I'm calling D1.toString. and I'm going to output d1.toString. d1.toString, remember that d1 knows its own data members, so it knows 13921 is its current data amount assignment. In d1.toString, I'm going to call the toString method in the header file. toString as a member function returns a single value as a string. I'm going to declare a variable by the name of dollars to type string, and I'm going to initialize it with the braces of the process within the braces, and that's using the toString method. Again, the toString, I'm sending amount divided by 100. Now this is d1.toString, where its d1.amount of 13921 divided by 100 would be 139 with integer division. Next, we have declared cents as a variable within this local method. And cents as a variable is going to be initialized with the result of what's within the braces. I'm going to call toString. Remember, this is d1.toString, so I'm looking at d1.amount is 1329. Get 1329, and I'm going to use integer arithmetic to retrieve the remainder with the mod operator. So 100 goes into 13291, 1, 3, 2, with 91 as a remainder. Integer arithmetic, our remainder is 91. So cents is assigned to the remainder, which is 91. Now continuing, the absolute value of 91 is 91. That will be assigned to cents. The next line is we're going to return the string dollars, and dollars is equal to 139. We're going to append a decimal point. We're going to continue with output and test cents size. Well, cents size is 91. That's 2 characters. 2 is not equal to 1, so we'll do the false test, which is nothing. That's a double quote, nothing's going to print. And then I append and output cents value, which is 91. And I guess actually it's 1321. One three nine, 132. Cents is D1 dot amount 139.21. So 139.21. Our remainder is 21. when we do long arithmetic. Integer arithmetic, 13921, 100, integer arithmetic, 13921, 1, 39, bring down to 2, 100, 92, 1, 9, 900 with our remainder of 21. So we assign since a remainder of 21, and it returns, the since size is 2, so it returns 2, 1, 13921. That was my math error, sorry. So we've gotten our first line of output after adding D2, which is 1579 monetary value, into D1, which is 123.45 in monetary value. D1 is equal to the sum of those two amounts. Well, they continue then with a couple of additional outputs, demonstrating that we can manipulate addition and subtraction as long as we have like-class objects. So in line 18, of our source code, we're going to output some additional data. This is line 18, and we're doing output, continuing to trace and dissect the source code, as well as making sure we're getting the output established. So we're going to output after subtracting D2 space and open paren is quoted. Now I'm going to continue to output D2.toString. So I'm going to call D2.toString. ToString is a member function of our object $amount. So any object of type $amount can use the ToString public member function. So D2 can use the public member function ToString. So in the header program, I've called the member function ToString, which returns a string. String dollars. Now, dollars is a local variable. It's going to be initialized with the quotes. ToString, I'm calling the ToString method again. ToString with D2. The object I'm using is D2's.toString. So D2.amount, D2.amount is 1576. And I'm going to use integer arithmetic and divide by 100. So my result is 15. Integer arithmetic, we truncate, get the integer quotient only. We're going to declare cents in ToString as a local variable known to that method during its duration of execution. We're going to call ToString, ask for the absolute value of, and we are working with the object D2. Its amount is 1576. We need to do modular arithmetic, divide by 100 and return the remainder, and the remainder is 76. Now I have D2 $2 dollars and cents, local variables, while I'm using this method. So I can return dollars, which is 15. I'm going to add a quoted decimal point. I'm going to continue to add cents.size. Well, the size of cents is 2. 2 is not equal to 1, so I'm going to do the ternary false path, which is nothing. And I'm going to append cents, and cents' value is 76. So I have added the 2.2 output converted to monetary value now. I have a quoted, close quote, a space from D1, space, open parenthesis, close quote. And now I'm supposed to call D1.toString. D1 is a dollar amount object, and dollar amount objects know how to complete the task of their public member function toString. So my toString member function is in my .h header file. D1.toString, I'm going to create a dollars variable of type string. I'm going to initialize with the braces D1.toString. D1.toString is 13921. But I need to divide it by 100. And integer arithmetic would be 139. Continuing, I'm going to initialize a string variable of cents. I'm going to initialize it to the result of what's within braces, toString dot D1 dot amount. D1 dot amount is 1329. Here I go again. 13921. But I need to divide by 100 to get the remainder, and the remainder is 21. Integer remainder 21. And now I'm going to return dollars. So returning dollars to my output, dollars is now 139. I'm going to quote period, quote, append cents.size. Cents.size is 2 characters. 2 is not equal to 1. I'm going to do the false path, which is nothing, and then append or print out cents value, and cents value is 21. So in the calling function, D1.toString is now output as a monetary value. I continued with a quote to print the close parenthesis, a comma, and D1 space equals space. And now I'm going to call D1.subtract. Sending D2. Now D1 is a dollar amount, class object. So I have D1 in hand, and I'm going to call its member function subtract. So D1 knows how to subtract, and we're going to subtract A dollar amount is shared as a object data type, and we're going to use right as the local variable name. So subtract, we're passing a dollar amount class object, we're going to reference it as right within the processing of this function. So I called D1 subtract method. I'm sending a dollar amount data type. Right is a dollar amount data type, so D2 is now assigned to the local variable right. As I continue with the subtract processing, I have subtract amount, which is D1 in this case. I called subtract with D1 in hand. D1 dot amount minus equals. And right dot amount. Well, right dot amount is pointing to, it is a local variable of type dollar amount, and it's pointing to D2, which was shared with it. So right dot amount is 1576. D2 was passed to right as a dollar amount, so right is pointing to D2's dot amount. Now with the minus equals, we're going to take the current value in D1 dot amount and subtract from it the current value in D2. D1 dot amount is 13921, and I'm going to subtract from it right, which is referring to D2 dot amount. Right refers to the dollar amount object D2, which is 1576. So D1 amount is going to subtract from it 1576 and assign D1 dot amount that new value. 13921 minus 1576 is 132345. So D1 dot amount is now equal to 1, 2, 3, 4, 5. D1 dot amount is reassigned to 1, 2, 3, 4, 5. So I've modified the D1 object, and now I want to output D1.toString. Remember that class objects of dollar amount maintain their own data members and can access any of the class object member functions. So D1 knows how to complete the task of toString. ToString in our object definition file. ToString is going to return a single string $. So I'm declaring a new variable of type dollars, known locally toString. Dollars is going to be initialized with the bracing. I'm calling toString amount divided by 100. Now this is D1 object, toString. So D1 now is 1, 2, 3, 4, 5. So dollars is 1, 2, 3, 4, 5 divided by 100. This is integer arithmetic. So I have 1, 2, 3, the integer portion assigned to dollars. And I'm declaring cents as a string variable known locally to this method. When we are done with this method, we no longer have access to these variables, local variables. Cents is going to be initialized to what happens within the braces. I'm going to call toString on amount mod 100. This is with D1 in hand, so D1 dot amount is 1, 2, 3, 4, 5. Mod arithmetic, divide by 100, and I want the remainder. The remainder is 45. 45 is positive, so 45 is assigned to cents. I'm going to return dollars, and dollars is 123. I'm returning 123. I'm going to return plus a period. Continue to output cents.size is 2. It's at 45. So the ternary logic is cents.to equal to 1 character? No, it's equal to 2. So I'm going to do the false path, which is nothing. And I'm going to append cents value 45. There's another example of subtracting that's output. And in this program, those first 3 lines of output are just manipulating through addition and subtraction 2 objects of type dollar amount. Referencing their data members, making use of the member functions. Any dollar amount object can make use of the member functions, and introducing the syntax in the header file of the toString, where we return a string, single string value, and some new functionality within that method when we check the size of the cents variable, the number of characters, using our ternary logic. Call a relational test. If it's true, we do the true portion, else we do the false portion. So line 23 is another example of manipulating our dollar amount objects through subtraction, calling the toString to convert to a monetary value and output. Well, then we really start the processing of our interest program. So compound interest calculations continue now. And in line 28, we're going to be outputting enter integer interest rate and divisor. So this is just all quoted material. Enter integer rate and divisor, for example, and then we force a new line. And we have this chart that we're building. For 2% enter 2 and 100. For 2.3% enter 23 and 1000. For 2.37% enter 237 divided by 10,000. So 237 divided by 10,000 is convert to percent 2.37. So we're just doing our conversions of percentage in decimal points back to integer representation for our rate, and then what's the appropriate divisor for precision. So we are to enter the input rate, and the rate is going to be an integer data type, so I'm going to input 5 and a space bar at the keyboard. So you'll see 5 and a space bar, and I'm going to enter 5%, so I want my divisor to be 100, so I'll enter 100. 5%, if I want to represent 5%, I'm going to enter 5, and 200 will be my divisor. So I'm converting percentage rates to integer values. And we input the rate and the divisor amount. So rate is 5 and divisor is 100. At line 37, we instantiate a new dollar amount object by the name of balance, and we're going to initialize it to the principal amount, but in pennies. We're converting everything to pennies. So our new dollar amount object by the name of balance, dollar amount has, as a class object, has a private amount data type of type int64_t. And as I instantiate, the private data amount will be initialized to 0. So instantiating the dollar amount, so we have balance dot amount is initialized to 0 on instantiation, and now we're going to initialize it through coding to $100,000. So just so you know, $1 equals 100 pennies. $1,000 equals 1,000 times $1. So 1,000 times $1 is equivalent to 100 pennies. So I substituted for $1 100 pennies, and multiply 1,000 times 100 is 100,000 pennies. So we're converting from dollars to pennies. So my monetary value principal amount is $1,000. In pennies, it's 100,000 pennies. Principal amount in pennies. Next, we see out initial balance in quotes. So I have initial balance with a space. Then I want to output balance.toString. Balance is a dollar amount class object, so it knows how to return its toString. And it will, toString will convert to its monetary value. So I'm calling balance.toString. In toString, the method in my header file, toString is going to return a string. I'm going to declare dollars. So dollars is declared and known locally to toString. I want to assign dollars, what occurs within the braces, and that's two-string amount divided by 100. So amount, balance dot amount is 100,000 divided by 100. We'll assign 100. We'll assign 1,000 to balance. So dollars is assigned through integer division, the integer quotient, 1,000. Next, I declare a cents variable, balance toString dot cents. Cents is going to be initialized to what's within braces. I'm going to call toString, looking for the absolute value of amount mod 100. So with balance in hand, balance dot toString, I'm going to send 100,000 and 100,000 divided by 100 is 1,000 with a zero remainder. So there's no remainder. So zero remainder as an integer remainder. Cent size is equal to 1. Cent size is equal to 1. So keep that in mind. We're right here. We're going to return dollars, which is 1,000 plus a period plus cents dot size. Cents dot size we said is 1. We have an integer remainder as 0, so the cent size is 1. If 1 is equal to 1, we append another 0 to output. And following the true path, and then we add cents, and cents has a 0 remainder, so we add 0. So initial balance is $1,000 converted with our toString to monetary value representation. We're going to display the year and the amount, and we have, let's see, year is displayed, and then we have this string, amount on deposit, output in a field width of 20. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's my 1 to 20 field width, and I'm going to output amount on deposit, and it'll be right justified. So your string is right justified within the set width field. Field is 20 characters wide, and we're going to output amount on deposit right justified. And now we begin to calculate with our for statement. For, there's the begin block and the end block. So I'm going to execute the body of the loop as long as the condition of the for is true. Unsigned, that means it's a positive integer. Year is assigned 1. Here's int, it's assigned 1. in a set with year is 1, is year currently at 1 less than or equal to 10? Yes, that's true. So I'm going to process the body of the loop. Processing the body of the loop, I have balance.add interest. I'm going to send rate and divisor. So line 46, balance.add interest. Okay, so I'm calling balance.add interest. Balance is a dollar amount object, so I'm going to go to my dollar amount.h header file for definitions, and I see that there is a dot add interest method. So with balance in hand, I'm transferring rate and divisor, and rate and divisor were initialized to rate was initialized to 5 and divisor was initialized through data input to 100. So now rate is equal to 5 and divisor is equal to 100 in this method for the duration of this method. So add interest rate, integer division is received. Dollar amount is a data type. It is a type of object, dollar amount. So we have another dollar amount data object named interest, and it's going to be declared to what's within the braces, amount times rate plus divisor divided by 2, close parentheses, divided by divisor. Remember, this is all integer arithmetic and an initialized amount of the object interest. Now my arithmetic in line 28. I have amount times rate plus divisor divided by 2, close parentheses, divide by divisor. And this is all integer arithmetic. Remember, we're declaring now amount.interest, so this is interest.amount. That we're declaring, and it's amount times rate, which is 5, It's balance dot amount, which is balance dot amount is 100,000 times 5 is our rate, plus divisor is 100, divided by 2, and then divided by 100. 100,000 times 5 is 5,000, plus 100 divided by 2 is 50, divided by 100. So now I have 5,050 divided by 100. Is integer 50. So this is 5,000 plus 100 divided by 2 100 divided by 2 is 50, divided by 100. Oh, 500,000, sorry. 5 times 100,000 is 500,000 plus 50 is 550. And integer arithmetic would be 50, 50. And let's see, 500,050 divided by 100 would be 5,000. Now we are initializing with our call. We're initializing interest dot amount. So interest dot amount is now initialized to 5,000. You gotta do your arithmetic right and read your code correctly. And remember, it's integer division. All right, that's first time through our loop. So we're going to go back. And we have initialized balance.add interest. Make sure we've completed that method. We've declared interest. We've assigned interest.amount to 5,000 with this initializing statement. And now we're going to add dot interest. And line 46, we output year, which is 1. Year, which is 1. In a field with the 20 again, we're going to output balance to string. Add dot interest. So add dot interest, it's balance dot add dot interest. So add method is add a dollar amount, and we're adding interest this time, so interest will be pointed to by right. So add interest. We have our dollar amount, we're passing interest, and right will now point to the object of interest. And we have amount plus equals right dot. And amount is balance dot amount plus equals right dot amount. Now balance dot amount is currently 100,000 pennies, and we're going to add 100,000 pennies plus right dot amount, but right dot amount is really pointing to interest dot amount, as interest was passed to the add method. Interest was passed as a dollar amount. Right is the variable pointing to it in this member function. So right dot amount is 5,000. So balance dot amount is going to be reassigned $105,000. So balance is reassigned $105,000. 1,000 pennies. Sorry. All right, first time through the loop. Now we're ready to output the year. This is year 1. And in a field width of 20, so we're going to follow with this field width of 20 spaces. We're going to write justified balance.toString. And of course, balance knows its own method, toString, and toString we used several times now. It converts pennies to monetary value with integer division and integer modular arithmetic, and then uses the cents size to determine how we output the cents variables. So balance.amount is now 105,000 pennies. Converted, we will have $1050.50. And if you look at your output on page 174, in year one, amount on deposit is $1,050. So tracing your variables, tracing your class objects, knowing that class objects continue to know their own data items. Balance.amount, interest.amount, right refers to interest.amount. Class objects always know their data member values throughout their lifetime. You can go ahead and run the program and see how it calculates years 2 to 10. And I would trace maybe 2 or 3 more executions of calculating the compound interest. Tracing, that means doing what I'm doing, follow the code, and trace with your visuals as you need to. Remember that all class objects have access to their member functions, and all class objects know their data values with D1 dot amount, D2 dot amount, balance dot amount, initial dot amount, maintaining each of their own unique data items and values within current memory. All right, my data project has been set. I did set my project properties, C++, precompilers to not using precompiled headers, applied and clicked OK. I made arrangements for my source code folder to be added, the student data file shared, and source code by the name of figure_05-07-08.cpp, which is my driver program. It has an integer main method that drives the processing of the program. I also made arrangements to add, and you can add an existing or add new, name it, and then copy and paste the header shared source code. Make sure that your header file is named correctly. If it is not, you can rename. And we'll try running, of course, with Control F5 so we don't activate the debugger. And here's where we were manipulating, adding and subtracting. We're just documenting that adding D2, its current value, into D1, its current value converted to monetary representation, is equal to the result. Subtracting the current monetary value from D1's current monetary value. D1 would be reassigned. And after subtracting D1's current value, monetary value, from D2's current monetary value, we get, and we're just evidencing that D2 dot amount could hold a negative value with our int64_t data type assignment. And then maybe more so, we're looking at the compound interest calculations, and we have our directions. This was our little chart, if you will. If you are wanting to use 2%, enter as 2 space 100. If you want 2.37, enter as 237 space 10,000. So we're converting our rates in percentage to integer rate and a divisor amount. So our first input example is the one we worked out longhand together, where we enter an interest rate of 5 and 100. Let's try an interest rate of 5.25. So 5.25 would enter as 5.25, and our divisor would be 10,000. Enter, and the program calculates. The initial balance was $1,000. We have balance.amount initialized to 100,000 pennies. We calculate and convert back to monetary value for our output of $1,000. In year one, we're making use of some type of tabular referencing using our set width. Amounts are placed right justified within the set width field of 20. If your characters are more than 20, it would expand and continue on. And you might have to reset to have things align well for you in the future. 20 seems to work for us here, year 2, 3, 4, and year 10. So this is a program you will want to trace and try to do what I did for a couple more years of output, to trace through the referencing of your objects and the reassignment of their data values. All right, thank you very much.